So hello everyone, hope you're doing good. Welcome back to my channel. Today we are at day 16 of the June daily Leetcode challenge, and we have finally a hard level question of us. Till now, whatever we have seen in the June daily Leetcode challenge, either it was in the medium level or in the easy level, and we mostly had questions on random things or related to DP and binary search trees and trees in general. But finally, we are having a question, hard level question out of us. Hard in the sense like for getting the approach, you will really have to dig a lot. But once you get the approach, it will be slightly easier, right? Let us see what the question is. It's question 1569. Number of ways to reorder arrays to get same BST. So before going to this question, I am hoping that you are aware of what is BST, because see, recently we had a question, like I think 2 or 3 days back we had a question on BST in which I explained to you in detail. It was on the easier side. That's why I spent a lot of time explaining what is BST and what is property, and especially when we talk about BST, what is special about it or a travel cell whenever we talk about BST, right? So those things we talked, and in this question we'll directly jump into the properties of DS. Like only the name is given at BST, but we are supposed to know its properties, right? We will discuss them also in general, but we will just give you a hint. You are supposed to know it on your own, right? Because we already discussed that. So now come to today's question. It's on a higher side, and let's see what the question is. Given array nums, okay, you can see the input basically. Here only a single array is given, which is called nums, okay. So given array nums representing a permutation of integers from 1 to n, okay. What is n is the length of the given nums array, okay. We are going to construct a binary search tree BST by by inserting elements of nums in order into an initially empty BST. Find number of different ways to reorder nums so that the constructor BST is identical, that is formed from the original array nums. Okay, so given see they have given example. If the original is 2 and 3, so you can see that the first one will always be the root of the main BST. Okay, now the elements which are less than 2 will go to its left subtree, and the elements which are greater than 2 will go to its right subtree. Okay, that is the basic idea. So we'll have 2 as the root, 1 as the left side, and 3 as the right side. Okay, so because 1 is less than 2, so it will be going to the left, and 3 is greater than 2, it will go to the right. Okay, so that is that. And the next part is they are now trying to find the permutations which is going to be the same BST. Okay, so they have come up with the permutation which is 231. So see the order here, 1 and 3 and 2 and sorry and 3 and 1. Okay, these are the only things which is changing. See, because the root cannot change, that's why the first element always take it from me, it will never change. Okay, only these things are changing. Okay, that is what it is. Only one permutation is possible for a for a given array nums which is of length less than 3. Okay, and in this case it is length is equal to 3, still only one is possible, right? That is the basic idea. And also is the same BST, but 3 to 1 yields a different BST. Okay, that is see here. So for 213, one of the answer is 231. Okay, just keep that in mind. Why? Because see, in this case, 2 is the root. One is going to the left because 1 is less than 2, and 3 is going to the left because 3 is greater than 2. If you see this thing, this all the same thing happens. Okay, so it doesn't matter the order. Okay, because whenever the 2 is root, 3 will always go to its right, and 1 will always go to its left. Okay? But if you talk about this thing, here the root itself is changing. Here the root becomes 3. Here the root was 2. Okay, so this particular answer is a totally different BST. Okay, so return the number of ways to reorder nums such that BST formed is identical to the original BST formed from nums. Okay. Since the answer is large, return it modulo 10 power n+1. What it means is, see, you will see this thing always in very late code questions. What it means is, we have to modulo what to modulo. For example, if we have 5 and we're doing modulo 2, modulo means the remainder basically. Okay, whenever a number is large, we have to find, we have to do modulo by this number so that the remainder which we get is a smaller number. Okay, so it is within the range of an integer. Okay, integer has like 4 bits, so there is a maximum number where we can be stored in integer, right? So to bring it to that level, we are doing this. Okay, that is the basic idea. So see this thing, it's 213. Okay, the given num is 213, and the tree you are seeing here is like formed from the original num array. Now we have to find the variations or the permutations possible for this, so that the same tree same BST is achieved. We will try instead of the elements one by one. Okay, so one possible solution is 213, as you can see. So this is only one possible solution. That's why the answer is one. Okay, if you see this tree, there are some 5 answers possible other than the given number. Okay, so let us try to dig into the approach of doing this question. Okay, so the length of the number is going to be around 1,000. Okay, and all numbers are going to be distinct. So let us now try to dig some how to get this. Okay, So let us go through some of the basics first. Okay, in the BST, all elements that are less than the root, okay, less than the root value are going to the left subtree, okay, while all elements greater than the root are going to the right subtree, okay. That is the basic idea here. Okay, I think this is a very simple problem in BST. I think you should be doing this. Okay, this whole question revolves around this. Okay, okay. Now we will go to the little bit deeper on it. Okay, as long as the relative order of the elements within each subtree is same. Okay, rearranging their positions in nums does not affect the construction of subtree. What is this? What we'll see this with example. Okay, a picture example, and then we will understand this. Okay. For now, let us understand how we are going to do it using the DP. Okay, dynamic programming. So we are defining a term here, defense of nums. Okay, let it denote the number of permutations of nums that result in the same BST as nums. Okay. So yeah, and see whenever we define a DP, see it's basically recursion, right? We always have to define a base condition. What is the base condition? We have dfs of nums equal to 1 when the length of the nums array is less than 3, which are the base cases. Okay. So why it should be less than 3? For example, see in this case, uh, see less than 3 means suppose we have only two elements. So one will always be the root. That is the first element will always be the root, and the other element will be its left or right subtree. Okay. That's why whenever the length is less than 3, we always have to return one, and this is going to be the base condition. Okay. Now come to this point. Okay, please read once again on your own, because see this question you have to understand on your own only. Okay, because we can understand only in some examples, but the ultimate understanding will come on your own. Okay, because in DP always things get a bit complex. As long as you have the real understanding, you will definitely understand. Okay, because whatever I try, I may not be able to reach your mind. Okay, so you only have to learn by your the examples. As long as the relative positions of the elements, okay, within each subtree is same. Okay, let us see by examples. Okay. For example, this is the numbers array given to me. Okay, always remember the first element will always be the root. Okay, so it is totally out of the question now, because root anyway you cannot change. If once you change the root, you know the answer is gone, right? That particular combination is never going to fulfill the our need. Okay, now come to the other elements, which are 4 and 5 and 1 and 2. Okay, so we can see we are grouping the elements in two ways. Okay, one is the elements which are greater than 3, and another is the elements which are less than 3. Okay, so always the elements greater than 3 are going to be in the right subtree, and the elements less than 3 is going to be in the left subtree. Okay, that is the first understanding that we are getting. Okay, now come to second picture. What we have defined DFS is basically the different combinations possible for length. So for an array of length, for the nums array. Okay, for the given nums array. So that is the basic idea. Then we are dividing into a left and right subtree, and then we are running a difference again on the left and right subtree. Okay, that is the basic idea. We'll see that now. But coming to this, see what I've explained you at this point. Please read it again. Now I'm going to explain how it works. Okay. So what how it works is this. Okay. For example, see this. I have the root as 3, then it comes 4 and 5. Okay. So now see that the order of 4 and 5 is changing. See, other two boxes are blank. Okay. Let it, whatever be the number in that, just ignore that. Just focus on 4 and 5. Okay. As long as 4 and 5, for example, as long as 4 is coming before 5. Okay. Till then, their order do not matter to me. See, only criteria is 4 should come before 5. Okay. Other than that, their positions do not matter to me. Okay. See, 4 can be here, 4 can be here, 4 can be here, 4 can be here. But in all these things, you are seeing one thing in common, that 4 is always coming before 5. Okay, as long as 4 is coming before 5, it doesn't matter to me. Why? Because see, 4 and 5 are going to be the right along the right subtree of 3. Okay, now if 4 comes before 5, that means 4 will be the root of the right subtree of 3. Okay, that is the basic idea. See, root should not change, right? That is the only thing which we are considering here. As long as 4 comes before 5, their indexes do not matter. Okay, so that's what we are seeing here. But how to find the number of ways? Here you can see that there are 6 ways of happening here. Okay, 6 ways in which it's happening, but how to find that? So let us do some maths here. Okay, it's very simple maths. It's called combinations. This topic, if I am not wrong, I studied in 8th standard in CBSE. Okay, it's called permutations and combinations. I will just going to show you how it works. Okay, see, there are 5 elements in this array. Okay, take any one array, there are 5 elements. Okay, one of them is root, which is fixed. Okay, remove that. 5 minus 1, which is 4. Okay, out of 4, I am going to fix two positions always. Okay, 4 is always going to come before 5. Okay, then how many ways of rearranging that? Okay, so 4C2. Okay, 4C2 it is called. Okay, because 4 positions, out of that 2 positions order is fixed. Okay, so I am going to call it 4C2. Okay, now just try to see 4C2 it's called. Okay, you will have to understand how it works, because I can just give you the gist. Okay, it's called combinations. You can just go and type this and you will get to know. Okay, it's called 4C2. Now how it works: 4 factorial divided by 2 factorial to 2 factorial. Okay, so it becomes 4 into 3 into 2 factorial divided by 2 factorial into 2 factorial. So it becomes 4 into 3 divided by 2 factorial. It becomes 2 into 3. That's it, right? 2 into 3, which is 6. Okay. As you can see, there are 6 numbers here. This is how we are going to get. Okay. The same thing we are going to see in the answer also. Okay. That's what we are doing here, basically combination. Okay. So now let us come to the answer. Remember, this is the base case. Whenever the length is less than 3, that means the elements are either 1 or 2 elements are there. In that case, the number of ways of getting the same order is 1 only. Okay, there's only one way of getting it. Okay, so that is the basic idea. See, here we are not. See, remember one thing. The answer says that other than this approach, other than this given order, how many orders are there? But in our answer, we are not doing that. Okay, we are calculating including this order. Okay, that is the basic difference. That's why you will see that when we are calculating this for nubs, okay, what is the difference? It was the number of permutation of nubs that result in the same BST, okay. Finally, we are doing minus one, okay. Why we are doing minus one? Because this will give me a number, okay. This number will include this combination also, okay, the given combination. That's why I have to subtract one and then remove a modulo, okay. So now let's come to the answer. So first of all, I'm declaring the modulo, okay. Then I'm declaring the defense function, which is going to be the recursive function, in which I'm going to do the DP, okay, dynamic programming, okay. So I'm declaring I must the length of the given nums array to be, okay. Then I'm applying the base condition here. If I is less than 3, then I have to return 1, okay. Then as I told you, I will be segregating the nodes, okay. Left nodes and right nodes, okay. So the nodes which are less than my nums, sorry, the less than the root, so it will be this smaller element set. The nodes which are greater than the root will be the larger element set, okay. That is what I'm going to do. So I'm creating left node array, okay, which will have all the elements of the given array nums, okay, all the elements of the given array nums, okay, which are less than the first element of the nums, okay, which are less than the first element of the nut, which represents the root, okay. So all the elements of nums which are less than 3, okay, will be in the left array, okay. Let's see what two are coming in the left side, okay. That is the basic idea. So for a nums, if a is less than the nums of 0, that is the first element, that is the root element. If it will be the left part, okay. Similarly, if it is greater than this, then it will be the right part, okay. If it is equal to that, see they've clearly mentioned the all elements are distinct. First of all, okay, they've clearly mentioned they are distinct. So there will never be a case that two elements of the same order are present. That is, those will be the root, at the same time nums and another element, that will never going to happen. That's why you're seeing a left, sorry, less than here and greater than here, okay. There will never be a case where greater than equal to sign will be needed, okay. That is the basic idea. So now what will happen is all the elements which are left the less than by root will be in this case. In that is this array. All the elements which are greater than by root will be in this array. Okay. Now we have to find the answer here. Okay. What we'll do? We'll do a similar thing on. See, this is the recursive call. Okay. The same function we are going to call on the subtrees. Okay. So this thing I'm going to call on the left subtree. That is the array which we have stored. The elements which are less than the root. Then we are going to call it for the right subtree. See, this will give me the number of permutation for all the left subtree, multiplied with the number of permutation for the right subtree, and this thing will tell me the current combination for the current situation. How many combinations are possible? This is what we saw here. Okay. See, this is what we saw here. Okay. See, within 4 and 5, how many are possible? That we'll see in the next calculation. That is in the summary calculation that we are not doing now. Okay. In this, we are doing the calculation for the current. That is, when, see, subarray calculation we will do in the recursive call. We are not doing that now. Okay. For this calculation, that is for the different orders of 4 and 5, how many such orders ways are possible? That's what we are calculating here, and that's what is being done here. Okay. As I told you, it's basically combination. Why we are doing -1? Because we are ignoring the root. Okay. The root is always fixed. So I am representing the length, right? So -1 means because we are ignoring the root. As I did calculation for this. Okay. Sorry, here. See, with here 5 elements are there. Do a -1 because I'm not taking the root. So four elements. Out of that, I'm fixing the number of elements in the left, which are sorry. Yeah, okay, take the number of elements in the right. In this case, they've taken the number of elements in the right. Okay. So less than 3 will be 2 elements. Okay. So 4C2 is the answer. Okay. Here the same thing they're doing. 4, that is the number of elements in the nums -1. C2, okay. C is the combination, okay. It's a Python function in this case. 2. 2 is basically the length of the node which is less than 2, okay, which is stored in left nodes, okay. So that is the basic thing. And then we are doing the modulo. So this will give me for the current nums array, okay. This will give me for its left child, and this will give me for the right subtree, okay. That is the basic idea. Finally, we are doing modulo in each of the cases. And remember why we're doing this -1? Because see, ultimately they're saying that other than the given sequence possible. Say the question also that I mentioned. It is a number of ways of reorder says that the BST formed is identical to the original BST. Okay, so they don't want to count it again. This string should not be counted again. Okay, other than this, how many are possible? That's what they're trying to say. That's why from the original number, I'm subtracting one and then I'm doing a model of mod. Okay, this is the mod which they're asking us to do model with. Okay, so yeah, for that was the question. It's a bit tricky one. See, I hope you have understood this. This part is for see. Once the, as I said, the order with see for example, there are three elements which will go to the rest of tree. Okay, as long as the order is fixed, that is which one will come first, which one will come last. As long as the order is fixed, we can rearrange them internally. Okay, that is the basic idea as you can see here in this picture. Okay, 4 and 5. See, four is always coming before. See, four is coming always before 5. Okay, so now we can ensure this property is existing. At the same time, we can ensure they are in different positions. Okay, that is the basic idea. Ensuring that 4 always comes before 5, we can permute their positions. That is the basic idea. Okay, that's what we are doing with combinations. Okay. So yeah, friends, that was all for today. If you want to ask me to comment, well, this was a tricky question as I mentioned in the starting itself. If you know the trick here, you will be able to solve this. But see, whenever you see such a question, lead code, just try to understand what it depends. Okay, you did not be thinking also or challenging also that how should I solve if I get this in interview. Okay? In interview, you will definitely get hits if you get this kind of questions. Okay, so you don't have to worry about that. So yeah, friends, that was all for today. Uh, this was our higher side, but definitely you should learn something from it. That's something which I want to conclude. See you tomorrow. Thanks a lot.